Okay, today we're going to be doing a little activity with plate tectonics. But first of all, we need to talk a little bit about the Earth and maps and latitude and longitude, because we're going to be plotting locations on the map. See, what we want to do is we want to learn about how the plates are related to features on the Earth, like volcanoes, mountain ranges, and earthquakes. And actually, what we're going to do later on in this class is, as we finish our plate tectonics unit, we're going to talk more about earthquakes and volcanoes in depth. So this is kind of a good connection between the two units. But if you look at the Earth, and this is obviously not the real Earth, this is just a globe, but it does kind of look like the Earth. At least it's the right size, the right shape, right? And it's a sphere, right? So pretty much a sphere. And when we want to measure places on the Earth, we use two coordinates. So one is called longitude, and basically you start at the poles. So from pole, this is the North Pole, to the South Pole, you draw lines. All right, and basically there's a line every degree around the Earth. So it's 360 degrees, and that makes 3 lines from North Pole to South. 360 lines from North Pole to South Pole. And these are called lines of longitude. Now, the 0 degree line goes through Greenwich, England. So here's Great Britain here, and this is the 0 degree longitude line. Okay, goes down like this, right through there. And instead of going from 0 to 360 and numbering them like that, what they do is they go from 0 to 180. So there's east longitude, which is measured starting at Greenwich, England, and then going east. And then there's west longitude, we measure going west from there, all right, until we get to 180. Now, the other coordinate is latitude. That starts at 0. 0 is a circle around the middle of the Earth called the equator. That is 0 degrees latitude. And then latitude is measured north from that line and south from that line in degrees. Now, the interesting thing about these two, or the difference between these two, is that lines of latitude are parallel with each other all the way around the Earth. So if you look closely here, I don't know if you can see it on this, but here's the equator's a line of latitude, and here's one right here. It is parallel to the equator. All right. The other thing is that the distance between lines of latitude is the same as we go up the Earth. That is not true about lines of longitude. 2 lines of longitude are much closer near the poles than they are at the equator, because, of course, the Earth is much wider at the equator. Now, the problem is when we go to a flat map, which is what you're going to be working with, when we go to a flat map like this, we have a problem because it's not a sphere. And so what do we do about that? We have to distort the image. So if you look at this map, which is the one that you're going to be using, we see that lines of longitude are across the top, and then degrees longitude are across the top, and then degrees latitude are down the sides. Now, there's 2 distortions on here. For one thing, the degrees longitude, or the longitude lines, do not join at the top. They can't, because this is a flat piece of paper. That distorts the image. For example, it makes Greenland much wider than it really is up here. Greenland is actually a small island up here. It's not as big as the United States as it appears on this map. The other thing is, on this map, the lines of latitude do not appear to be equidistant with each other when they really are on the Earth. Okay? Now, what you're going to do with this map, so you're going to have this map here, and then you have on your handout, after the instructions, which you should read, you've got a list of volcanoes with their longitude and latitude coordinates, A through Q. You've got a list of earthquakes, and then a list of mountain ranges. And what you're going to do is plot these all on the map. So let me just show you how that's done. Let's take, let's look at Tambora. Okay, so this is a volcano. Its letter is J, and it's 120 degrees east longitude and 10 degrees south latitude. So 120 degrees east longitude, I start at the 0 and I go east 120 degrees, so I'm tracing right down this, that's convenient, and 10 degrees south latitude, so that would be, all right, it's on this line. Here's 0 degrees, whoops, sorry, I can't see that. So this is 120 longitude, this is 0 degrees latitude, this is 15, so 0, 5, 10, so 10 degrees would be, looks like it's somewhere around here. Now what they want you to do is put the letter, and this is Tambora, and its letter is J, so I'm going to put a J right there. Okay, see how that works? And then just do that for all of the volcanoes, and then for the earthquakes, and then for the mountain ranges. All right, and now lastly, what they're going to want you to do is sketch the plate boundaries on this map, and for that, you can do this. So you can use this map, and then I want you to transfer the plate boundaries onto here, okay? Now, as I was doing this, as I was setting this up, I'm like, oh, wait a minute, they could just plot things right on this map here. I don't want you to do that for 2 reasons. One is this map is a little smaller, and it's going to be harder to get accurate, to be precise with the degrees here. But the other thing is, I think it's going to be good to actually do the process of transferring the boundaries onto this map so that you can get used to where those plate boundaries are. All right, so you're going to use this map at the end to trace the plate boundaries onto here, and then use the whole thing to answer these 4 questions on the back. All right, and have fun with that, and we'll see you tomorrow.